Hello students, in this part we will cover the problems of motion of particle moving along the curved path and having its own mechanism and having its own acceleration. In the previous lecture we had covered the problems of curvilinear motion but of projectile. Projectile is a special case of a curvilinear motion where object is thrown at some velocity in any direction other than vertical and subsequent motion is under the influence of gravity. Projectile does not have its own mechanism to have its own acceleration. In this part, we will cover the problems of curvilinear motion other than that of projectile, right? That examples like motion of the aeroplane flying in the sky and tracing the curved path, or motion of the car tracing the curved path on the road. Such problems of the curvilinear motion are solved either by resolving the motion components in horizontal and vertical direction, which we call it as rectangular components, or by resolving the motion components in normal and tangential directions, which we refer as normal and tangential components. Depending upon the data given and depending upon the unknowns, we decide to resolve the components into x and y directions or along the normal and along the tangent. To begin with, we start with the rectangular components. Now, first you can see that, look at this diagram. We are considering here there is a particle which is moving in a plane along the curved path as this is shown. At a certain instant, it is at point P having coordinates x and y. Position vector of point P with respect to origin will be r bar, that will be xi plus yj. As particle moves, its position changes. So rate of change of position with time gives you velocity. So if you differentiate the position vector with time, you get velocity vector. So dr bar by dt. So dx by dt I plus dy by dt j. Dx by dt is vx I, dy by dt is vy, so vy j. So this becomes velocity vector. If you want to find the resultant velocity, then you have to take mod of velocity vector, that is vx square plus vy square square root of that. Then to find, now here we have shown at point B, this is x component velocity, this is y component velocity. This is resultant velocity. So resultant velocity is square root of vx square plus vy square, and tan theta. Theta is the inclination of the resultant velocity with x direction. So tan theta is vy upon vx. Vy is dy by dt, vx is dx by dt, dt gets cancelled, you get dy by dx. Now, what is dy by dx? Is slope of tangent. So this gets me the very important note which is required for solution of the problems of curvilinear motion. So what I have written here, this shows that resultant velocity during curvilinear motion is along the tangent. It is always along the tangent to the path. Again, I read, and hence resultant velocity of the particle during curvilinear motion is always along the tangent to the path. Hope you all are understanding it. This is a very important note which is to be remembered, that during curvilinear motion, resultant velocity is always tangential to the path. Now further, as velocity vector was given to you, now we differentiate it one more time with respect to t. You get acceleration vectors dv bar upon dt, that is dvx upon dt I plus dvy upon dt j. So dvx upon dt is ax, dvy upon dt is ay. So acceleration vectors axi plus ay. So resultant acceleration is mod of acceleration vector, that is square root of ax square plus ay square. Now, sometimes depending upon the data given or unknowns, we resolve the velocity and acceleration components along the normal and along the tangent. What is the distinct advantage you get it when you are resolving the components in normal and tangent direction? As we already know that resultant velocity is always tangential to the path, so velocity will have only one component, that will be along the tangent, whereas acceleration will be resolved along the tangent to the path and along the normal to the path. Now, look at the diagram. Here you can see that again we are considering there is a particle which is moving along the curved path. At a particular instant, it is at point P. All right. So we resolve the velocity and acceleration along the tangent. This is tangent direction and this is normal direction. First, you should understand that normal direction is such that it is always directed towards center of curvature. So curvature is like this, it is this way. Suppose curvature is this way, it will be other direction. So remember that normal acceleration is, direction of the normal acceleration is such that it is always directed towards the center of curvature. This is the pointer has been written. Now along the tangent you'll have velocity component and tangential acceleration. Along the normal acceleration. Then resultant acceleration will be an square plus at square. How do you get at? AT is rate of change of velocity with time. As velocity is along the tangent, if you just resolve the velocity, right, dv by dt, it gives you AT. Mind it that if you are in the rectilinear motion, it gives you directly acceleration. But if you are in the curvilinear, solving the problem of curvilinear motion, rate of change of velocity with time gives you tangential acceleration. And what is normal acceleration? It's identical to the centripetal or centrifugal acceleration, what we learn it at PS level. Here an is v square upon rho. We don't write it r, we write it here rho. Rho is radius of curvature, and if it is a circular path, I can use r also. But many times in our problems, we have parabolic path, we have elliptical path. So that's why we, instead of using the notation r for radius of curvature, we prefer to use in this chapter rho. All right. Out of an and at, and now resultant acceleration is an square plus at square, square root of that. And suppose alpha is the angle what the resultant acceleration makes with the direction normal acceleration, so tan alpha will be at upon an. All right, normal acceleration signifies change in direction, at tangential component signifies the magnitude. So with this, students, now further, the if equation of path is given, if the particle is moving in a plane xy, then equation of path will be a relation between y and x. Equation of path will be relation between x and y. If you want to find radius of curvature from equation of path, differentiate equation of path twice with respect to x. So you will get d2y upon dy by dx, then d2y upon dx. Then this radius of curvature formula is used. Its derivation is covered in mathematics. So in mechanics, we don't talk about this derivation. Rho is equal to 1 plus dy by dx square raised to 3 by 2 divided by d2y upon dy square. We also use one more formula. When acceleration and velocity vectors are given to you, you can also find the radius of curvature using this formula. Actually, students, this formula as well as this formula both are one and the same thing, only different formats are there. Now we are ready to start with problems of the chapter. We start with problem number 1. This part, student, is relatively simple. Straight problems are there, short problems are there, although it's very important from examination point of view. Most of the time you'll get a problem from this part. Mostly problem, theory is rare, very rare. Whatever I have covered, as they ask it sometimes, write a short note on normal and tangential acceleration or normal and tangential components. Now problem number 1, we read. A particle travels on a circular path whose distance traveled is given by s is equal to 0.5 t cube plus 3t meters. If the total acceleration is 10 meter per second square at t is equal to 2 per second, find the radius of curvature. Students, you are given with s in terms of t, 0.5 t cube plus 3t. I can differentiate it with respect to t. So what I'll get is ds by dt. That is velocity. 0.5 into 3t square plus 3 is equal to 1.5 t square plus 3. If you differentiate it further one more time, you get tangential acceleration. As the particle is moving along the curved path, at is equal to dv by dt. That is 3t if you differentiate velocity expression. At t is equal to 2 seconds, total acceleration is given. So first, at can be determined. At is 3t, 3 into 2, that is 6 meter per second square. And velocity is, substitute the value t into this, you get velocity also. Then normal acceleration can be arrived at as total acceleration is given, tangential acceleration is given. So an is going to be square root of a square minus at square. A is total acceleration given 10. Tangential acceleration you have arrived at 6. So 10 square minus 6 square, that is 8. Now you want to find normal acceleration is equal to, normal acceleration is known to you. Normal acceleration is v square upon rho. Normal acceleration we substituted. Velocity is known to you 9. Rho is radius of curvature. That's what has been found, and that's what is asked. So you can see that displacement was given in terms of time. We differentiate once, you got velocity. Differentiate one more time, you get at. Then at t is equal to 2 seconds, we got velocity and tangential acceleration. Total acceleration is given. So we get first normal acceleration, and the normal acceleration is equal to v square upon rho. That gets me radius of curvature. Okay, we read. I read the second slide. A car starts from rest on a curved road of 250-meter radius and accelerates at a constant tangential acceleration of 0.6 meter per second square. Determine the distance and time for which the car will travel before the magnitude of total acceleration attained by it becomes 0.75 meter per second. Well, students, what is given in the problem? The radius of curvature is 250 meter. Nothing is said. That means particle must be moving along the curved path. That is why radius of curvature is constant. He has given one more thing. Tangential acceleration is constant. If tangential acceleration is constant, then can you see that I have considered the motion is from A to B. AT is constant means along the tangent acceleration is constant. AT, AT, AT. Can you see that along the tangent at 4-5 locations I have shown tangential acceleration. So this is signifies that for this curvilinear motion, tangential acceleration is constant. Students, when tangential acceleration is constant, we can use equations of motion along the curved path, along the tangent. I have written this note, you can read it. During curvilinear motion, if AT is constant, equations of rectilinear motion can be applied along the tangent, right? So equations of rectilinear motion are V is equal to U plus AT, V square is equal to U square plus 2S, S is equal to UT plus half AT square. These three equations of motion can be applied if AT is constant and you apply the motion or equations of rectilinear motion along the tangent. And all right, and whenever you are applying the rectilinear motion equations along the tangent, prominently you should write as a heading motion along the tangent. Now, anyway, in this problem, this car starts from rest at E. So velocity at A is 0. At point B, its velocity is given to you 10.61. It is arrived at. How you arrive at velocity at B? He has given at point B. What is given? Total acceleration is given. At point B, total acceleration is given 0.75. You are given with 80. Can I find AN or not? Total acceleration 0.7 is equal to square root of AN square plus 80 square square root of. I can substitute the value of 80. I can find AN. 80 I have substituted, you got AN. But what is AN? V square upon rho, right? You know rho, you know AN, you can find velocity at. Once I find velocity at B, I wrote it over here. Then, since 80 is constant, I can take motion along the tangent from A to B. I have to write this prominent heading that we are considering the motion, tangential motion equation of rectilinear motion are going to be applied along the tangent from A to B. I have considered the S is the distance which is measured along the curved path, and T is the time what it takes to reach that. So we write the equations of rectilinear motion. Slight change will come when you are writing the equations of rectilinear motion along the tangent from A to B in the problems of curvilinear motion. Equation will be written like this: V is equal to U plus, instead of A, what we write here, AT. V is equal to U plus AT into T. V is velocity at B 10.61. Initial velocity at A is 0. Tangential acceleration 0.6 into T. That is, you get T as 17.6. Then this gets me the time period what the particle takes in covering the distance from A to B. To find the distance, I can use S is equal to UT plus half AT square. But since the final velocity is into consideration, V and S are into consideration, we prefer, as per our practice, V square is equal to U square plus 2 ATS. V is velocity at B 10.61. U is the initial velocity, that is 0. Plus 2 into 80. 80 is 0.6 into S. That gets you the value of S 93.81. Let's move to the next sum. Problem number 3. A train enters a curve of radius 800 meter with a speed of 72 kmph. That means radius of curvature is 800 meter and initial velocity is 72. Determine the magnitude of total acceleration at the instant the brakes are applied so that the train stops by covering a distance of 500 meters. That means after covering a distance of 500 meters along the curved path, it comes to rest. Also determine the time required by the train to come to rest. Assume AT is constant. Again, student, if AT is constant, you can again use equations of rectilinear motion along the tangent. Let's see what is it. Radius of curvature is 800 meters. Initial velocity is 72 upon 3.6 20 meter per second. Final velocity is 0. AT is constant and S is 500 meters. So we can use the motion along tangent. V square is equal to U square plus 2 ATS I have applied. Final velocity is 0. Initial is 20 plus 2 into 80 into S. So that gets you the value of AT. AT comes minus 0.4 meter per second square. It is indicative of what? It is under negative tangential acceleration. All right. Then we write V is equal to U plus AT into T. V is 0, U is 20, AT is minus 0.4 into T. You got T as 50 seconds. That is 1 unknown. He is asking you to find out the total acceleration just after the brakes are applied. You should understand that during the entire motion, it is constant. Normal acceleration is velocity based. So velocity just after the brakes are applied, velocity will be taken as 72 only. Why? Because there is no change, no time defined just after the brakes are applied. What is asking? Total acceleration at the instant when the brakes are applied, right? So we are finding the total acceleration when the brakes are applied. So velocity will be taken as 20 meter per second only. So normal acceleration is v square upon rho, v is 20 square upon rho 800 is equal to 0.5 meter per second. Then total acceleration is square root of an square plus 80 square. An is 0.5 and 80 is 0.4. Substitute them and you get the total acceleration, that is 0.64 meter per second square. This time the problems are many times asked in an examination for 4 marks. Quite simple, straight, and just you need to, not even 5 minutes are needed to solve such things. Okay, we take problem number 4. I'm reading some. To anticipate dip and hump in road, the driver of a car applies brakes to produce constant deceleration. Constant deceleration during curvilinear motion is indicative of what? It is constant. The speed of the car at is 100 kmph at bottom A of the dip and 50 kmph at the top C of the hump, which is 120 meter along. Distance along the curved path from A to C is 120 meter. All right. If the driver experiences a total acceleration of 3 meter per second square at A, total acceleration at A is given to you as 3 meter per second, and if the radius of curvature at C is 150 meter. So radius of curvature is not a constant this time. Even center of curvature is changing, right? Calculate the radius of curvature of dip at A and net acceleration at the point of inflection B and hump C. Well, students, in this problem, since AT is constant, it is given, we can apply equations of rectilinear motion. I mean, you can consider the motion along the tangent from A to C, and equations of rectilinear motion can be applied. So I have straight written the heading motion along tangent from A to C. Initial velocity at A is 100, so 100 upon 3.6, 27.7. Final velocity that is at C is 50 upon 3.6, 13.8. Distance along the curved path is 120 meter. So we apply v square is equal to u square plus 2ATS. V is 13.89, u is 27.78, and s is 20. So you get 80. We understood that 80 comes out to be minus 2.412. That is means during the entire motion it is under deceleration, and this is what he has mentioned also in the problem. It is produced a constant deceleration. So it is under negative acceleration. Now at point A, what is given at point A? Total acceleration is given, which is equal to square root of n square plus 80 square. Substitute the value of 80, what you got it, you get then A. An comes at A.11784. An is v square upon rho. Velocity value substitute upon rho. So rho comes out to be 432.61. So at point A, total acceleration was given. 80 we got it. An is A square minus A square minus 80 square. All right. Once you get An, then is v square upon rho, that gets you the radius of curvature. Then at point B. At point B, this is the point B. Can you see that? Here radius of curvature is of one nature. B to B further up to point B, radius of curvature is somewhere for this curvature, center will be somewhere here. For the curvature beyond B, center curvature will be somewhere. So the point B is the junction of two curvatures of opposite nature. So this such a point where the two curvatures of opposite nature are meeting is called as a point of inflection. So at point of inflection, radius of curvature is considered to be infinite. So that rho at B is infinite since it cannot be measured, since point B is the junction of two curvatures of opposite nature. All right. So An is going to be 0. Why An is going to be 0? Because rho is infinite. Then total acceleration at point B will be nothing but tangential acceleration only. That is minus 2.412 meter per second square. Then we come at point C. At point C, velocity at C is given to you, 13.89. Radius of curvature he has given, so I can find normal acceleration, that is VC square upon rho. Substitute the value of VC and rho, you get normal acceleration. Tangential acceleration throughout is same from A to C. So total acceleration is square root of An square plus 80 square. Substitute the value of An and 80. You get the resultant acceleration at c, which comes out to be 2.733 meter per second. Now we move to the other problem. Rest of the problems are also considered to be quite important, asked many times in the examination. I am reading some. An aeroplane travels on the curved path at point P. It has a speed of 360 kmph, which is increasing at a rate of 0.5 meter per second square. Velocity at point P is given 360, which is increasing at a rate of. That means velocity is not constant. It is increasing at a rate. So that means rate of change of velocity with time is tangential acceleration. That means tangential acceleration is given to as 0.5 meter per second square. Determine at P magnitude of total acceleration, angle made by the acceleration vector with the positive axis. Now, this is the diagram which is given to you in the examination. This problem has been asked a number of times in the examinations. Now, this is point P having coordinates 4 and 3.2 kilometer. This is equation of path y is equal to 0.2x square, and it is in kilometer units. Now, at point P, velocity at point P is 360 upon 3.6. This is going to be 100 meter per second. Tangential acceleration. What is tangential acceleration? dv by dt. That is what is rate of change of velocity or rate of increase of velocity is increasing at this rate. So that means it is directly given to us 0.5 meter per second. You are given with equation of path. You can remember it like this. Whenever equation of path is given to you, you can attempt for radius of curvature. What it is? Y is 0.2x square. Differentiate it twice with respect to x. First differentiation dy by dx 0.4x. Second differentiation d2y upon dx square 0.4. At point P, x is equal to 4 kilometer. So dy by dx is 1.6, which is dy by dx is nothing but slope of tangent, which we can call it equal to tan theta. So you get theta as 58 degree. So that means resultant velocity is making 58 degree angle with the x-axis. Anyway, now d2y upon dx square is 0.4. Now you use this radius of curvature formula. Whenever equation of path is given and you find dy by dx and d2y upon dx square, you should use this radius of curvature formula. What is this radius of curvature formula? Rho is equal to, in the numerator, 1 plus dy by dx whole square raised to 3 by 2 upon d2y upon dx square. Substitute the value of dy by dx and d2y upon dx square. You get radius of curvature. This radius of curvature will come out to be in kilometer units. Why? Because equation of path is in kilometer units, coordinates are in kilometers, so radius of curvature will also come in kilometers. 16.792. So it is 16792 meters. Now normal acceleration at point P will be v square upon rho. Velocity is known to me at point P 100. Radius of curvature I have found it at point P 16792. So I got normal acceleration. You have to find total acceleration, resultant acceleration. So resultant acceleration will be what? Square root of an square plus at square. Substitute the value of an and at, you get the resultant acceleration. But the problem does not get over here only. He is also asking one more unknown. What is asking? Angle made by the acceleration vector with the positive axis. He wants you to find out the angle made by the resultant acceleration with x-axis. So now again we'll have to draw the diagram. अभी देखो मैंने दोबारा से एक डायग्राम ड्रॉ किया where I have shown the same thing as it is. I have shown the tangent, I have shown the normal. Normal is directed toward the center of curvature. तो इस बाजू आएगा. This is x-axis. Along the tangent you have tangential acceleration. All right. You have the velocity also along the tangent. This tangential direction is making angle theta, which we understood to be 58 degree. Then along the normal you have normal acceleration. Your resultant acceleration is like this. I am assuming that alpha is the angle which the resultant acceleration is making with the direction of tangent. Now, what will be tan alpha? An upon 80. Substitute the value an 0.596, 80 value. You get alpha as 50. That means, looking at the diagram, you understand that resultant acceleration is making angle theta plus alpha with x-axis. Theta is 58 degree, alpha is 50. So that means resultant acceleration at point P is making the angle of 108 degree with positive x-axis. One more problem on identical concepts. Problem number 6. A point moves along the curved path. Again, equation of path is given y is equal to 0.4x square. At x equal to 2 meter, its speed is 6 meter per second. At x equal to 2 meter, its speed, I mean velocity is given, which is increasing at a rate of 3 meter per second square. That means this 3 is nothing but tangential acceleration. At this instant, find velocity components along x and y direction and its acceleration. You are given at x equal to 2 meter, v is 6 meter per second, and at is dv by dt, that is 3 meter. Y is 0.4 x square, dy by dx is 0.8 x, and dy upon dx square is 0.8. He is asking you to find out everything at x equal to 2 meter. So substitute value of x as 2 meter, you will get the value of dy by dx as well as dy upon dx square. Now students, he is asking velocity components. So theta is needed to us. What is going to be? How will we get one or two small steps are missing in this problem while making PPT. Doesn't matter, I'll just cover it. Now students, x is equal to 2 meter. You can find dy by dx. So that will be 1.6. What will be dy by dx? Will be 1.6. And dy by dx is nothing but tan theta as in the previous problem. You get the value of theta, which comes out to be 58 degrees. dy upon dx square is constant, 0.8. So Vx is v cos theta. V is 6, which is given to in the problem. And theta, we understood it that tan theta is equal to dy by dx. And again, I repeat that the step missing in the PPT is what dy by dx. Just to substitute the value of x as 2 meter. So dy by dx will be 1.6, which is equal to tan theta. Then theta comes out to 58 degree as in the previous problem. In the previous problem also, dy by dx, that is tan theta, was 1.6 only. So theta comes out to be 58 degree. Now Vx is v cos theta and Vy is v sin theta. So you got Vx and v. Now radius of curvature 1 plus dy by dx is 1.6, substitute raised to 3 by 2 upon d2y upon dx square, that comes 8.396. Now normal acceleration is v square upon rho. Substitute the value of v, substitute the value of rho, you get normal acceleration. Then total acceleration can be easily worked out because at is given to 3, an you have worked out 4.29. So total acceleration is square root of an square plus at square. An value and at are substituted, you get the total acceleration. Okay, let's move to the next one. That is problem number 7. If the y coordinate of a particle is given by y is equal to 6t square minus 5. Ax is given 14t and bx is given to 4 meter per second at t is equal to 0. Ax and is 14t and bx is 4 meter per second, t is equal to 0. Determine the velocity and acceleration of the particle at t is equal to 1. Students, you are given with y is equal to 6t cube minus 5. You can differentiate it once, you get dy by dt. 18t square minus 1. You can differentiate one more time, you get ay is equal to dvy upon dt, that is 36t. At t is equal to 1 second, you get vy, which comes out to be, substitute the value of t into this. You get 30 meter per second and acceleration ay, it is 36 meter per second square. So vy ay mil gaya. Abhi ax he has given as 14t, which we can write it as dvx by dt. Separate the terms, integrating both sides, you get Vx is equal to 14t square by 2 plus c. At t is equal to 0, Vx is equal to 4 meter per second is given in the problem. Substitute that, you get c1 as 4. So Vx comes out to be 7t square plus 4. Then at t is equal to 1 second, Ax is 14 meter per second square and Vx is 11 meter per second. Now you have got Ax and Ay. You have got Vx and Vy. Right? Draw a diagram, show Vx and Vy, and find resultant velocity, which we assume that making angle theta with x direction. So velocity is 11 square plus 13 square root of that, 17.0. Theta is equal to tan inverse 13 upon 11. You get. Similarly, draw another diagram showing ax and ay to correct direction. Ax, ay, vx, vy all are positive. Acceleration is making say angle alpha with x direction. Total acceleration is an square plus at square root of that. Substitute the value of ax and ay. You'll get the total acceleration. Then tan alpha is ay upon ax. Problem number 8. A point moves along the path y is equal to 1 by 3 x square with a constant speed. If during curvilinear motion speed is constant, that means tangential acceleration is 0. During the curvilinear motion, if the speed or velocity is constant, that means at is 0. What are the x and y components of velocity when x is 3 meter? What is the acceleration of the point when x is 3 meter? Students, you are given with the equation of path y is equal to x square by 3. Differentiate with respect to x, you get dy by dx 2 by 3x. Differentiate one more time, d2y upon dx square 2 by 3. At x equal to 3 meter, dy by dx is equal to 2 by 3 into 3, that is 2. But dy by dx is equal to tan theta. Tan theta is 2, so you get theta. He is asking you, with this value theta, you can find cos theta and sin theta. Then Vx comes out to V cos theta. Vy is V sin theta. Substitute the value of V and theta into this, you get x and y components of acceleration, what are asked in the sum. You can see that this problem has been asked number of times in various examinations, not only in MU, but in even in autonomous colleges also, like SPC and KG. Now, if V is constant, we understand it is 0. Now, first we find radius of curvature. 1 plus dy by dx whole square raised to 3 by 2 upon d2y upon dx square. I'll substitute the value of dy by dx 2. I'll substitute the value of d2y upon dx square. You get radius of curvature. Then normal acceleration is v square upon rho. You know the velocity, that is 8. You know radius of curvature, so normal accelerations are right. This normal acceleration is nothing but total acceleration also. Why total acceleration? Because it is 0. Next, problem number 9. A particle travels along the path defined by parabola y is equal to 0.5 square. If x component of the velocity vx is by 5t meter per second, determine the distance of the particle from the origin and the magnitude of the acceleration when t is equal to 1 second. At t is equal to 0, x is equal to 0, and v is equal to. This is something boundary conditions are given. He has given at t is equal to 1 second. T is he is asking you to find out the distance of particle from the origin magnitude when t is 1 second. So boundary condition is that t is equal to 0, x is 0, v is 0. Now, anyway, we start with he has given vx is equal to 5t. Vx can be written at vx is nothing but dx by dt. Separate x and t terms, integrate both sides, you get x is equal to 5t square by 2 plus 0. Boundary conditions are given to you at t is equal to 0, x is 0. So you get c1 0. So x comes out to be 2.5 t square. We also understand that ax is equal to dvx upon dt. So ax comes out to be constant, that is 5 meter per second square. Then what is y? 0.5 x square. Value of x is known to be 2.5 t square. Substitute the value of x into it, right? You get y is equal to 3.125 t raised to 4. Now, once you have the y with in terms of t, dy is equal to dy by dt, right? dy is dy by dt. So 3.125 into 4t cube. This comes out to be 12.5 t. Then ay is equal to dvy upon dt. 12.5 to 3t square, that is 37.5 t square. At t is equal to 1 second, you get ax, that is 5 meter per second square, and ay is this. So you can get resultant acceleration as square root of ax square plus ay square. Substitute the value of ax and ay, you get the resultant acceleration. We understand that at t is equal to 1 second, from this expression x is 2.5, and from this expression y is 3.125. So distance from the origin will be square root of x square plus y square. Value of x is 2.5, y is 3.125. So distance from the origin is arrived at. How come the distance from the origin is we are getting it directly x square plus y square square root of that? Since students, these are the coordinates. The coordinates will be in x and y direction. So distance of the point will be diagonal of a right angle triangle where x and y will be two sides meeting at 90 degree, and so diagonal can be arrived at using Pythagoras theorem, x square plus y square square root of that. Okay, let's students come to problem number 10 of the curvilinear motion. I'm reading the sum. A particle moves xy plane with velocity components vx is 8t minus 2 and dy is 2. If it passes through the point xy, that is coordinates of xy are given at t is equal to 2 seconds. Determine the equation the path traced by the particle. Find also the resultant acceleration at t is equal to 2 seconds. See, vx is equal to 8t minus 2. If you differentiate once, you get ax dvx upon dt 8. But vx is also equal to dx by dt. Separate x and t terms, integrating both sides, you get x equal to 8t square by 2 minus 2t plus 3. Putting the boundary conditions given to you at t is equal to 2 seconds, you are given with value of x as 40. Substitute the value of x and t into this expression, you get c1 as 2. So you get then value of c1 is substituted in this expression. So you get x is equal to 4t square minus 2t plus 2. Leave it as it is. Then we come to vy is given to vy, ay will be then dvy upon dt, that is 0. That means y component of the acceleration is 0. You also understand that vy is dy by dt. Separate y and t terms, integrating both sides, you get y is equal to 2t plus c. Putting y is equal to 4 meter and at t is equal to 2 seconds. Again, these are boundary conditions given to you here. X and y are given at t is equal to 2. So this gets you the value of y as 2t. That's y as 2t. So resultant acceleration is going to be ax square plus ay square root of that. Student, ax comes out to 8, ay is 0. So you get resultant acceleration as 8 meter per second. Well, equation of path is a relation between x and y. See, if the particle is moving along the curved path in a plane, then equation of the path will be relation between x and y. In this problem, you got it x as 4t square minus 2t plus 2. You got y is equal to 2t. So you can eliminate t. How you can eliminate t? Y is equal to 2t, so t is equal to y by 2. X is 4t square minus 2t plus 2. Just substitute the value of t into it. You get the equation of path. So remember that if you have x and y in terms of t, while solving the problems of curvilinear motion, if you have x and y in terms of t, you have to simply eliminate t. Equation of path can be arrived at, because equation of path in curvilinear motion is nothing but relation between x and y. Now, next, problem number 11. A particle moves in xy plane and its position is given by r bar is equal to 3ti plus 4t minus 3t square j, where r bar is the position vector of the particle measured in meters at time t second. Find the radius of curvature of its path and normal and tangential components of the acceleration when it crosses x-axis again. Students, position vector means what? X and y are given to you in terms of t. You are given with x in terms of t, that is 3t. Y is given to us 4t minus 3t square. And now he says last line, you have to find the radius of curvature and normal and tangential components of the acceleration when it crosses x-axis. So when the particle crosses x-axis, y coordinate will be 0 or not. So he is asking you to find out all unknowns like radius of curvature, normal acceleration, tangential acceleration when the particle crosses x-axis again. So put y is equal to 0. If you put y is equal to 0, right, then you get the two values of t. One is 0 and another is 1.30. T is equal to 0 corresponds to the beginning, that starts from rest. All right. Then we have and he says that when it crosses x-axis again means what? You cannot take t is equal to 0. You have to take t as 1.3. So when the particle crosses x-axis, then t is 1.3. Now let's take x. X is 3t. Dx is dx by dt. Ax is dvx by dt. You got vx and ax. At t is equal to 1.33 seconds, you got vx and ax is 0. Y is 4t minus 3t square. Vy is dy by dt. Substitute the value of vy is dy by dt. So 4 minus 16. Ay is dvy upon dt. Again differentiate with respect to t, you get ay. Then at t is equal to 1.33 second, vy is, substitute the value of t 1.333 second, you get vy as minus 4. Ay is minus 6. So velocity vector is vxi plus vyj, 3i minus 4. Acceleration vector axi plus ayj, you get is 0i minus 6. So velocity is 3 square plus 4 square square 5 meter per second. Acceleration is 6 meter per second square. You want to find the radius of curvature. This time equation of path is not given directly, but acceleration and velocity vectors are given. So you can use this formula. A mod of A cross A is V cube upon rho. So first you have to find A cross V. A cross V, ijk, this is AX, AY, this is VX, VY. You can see that when you solve this, you will get only K coefficient. In the plane curvilinear motion, when you take A cross V, you will get only K coefficient. Rest all coefficients will go off. I and J coefficient will not be appearing in the simplification. So you can see that I and J coefficient are going. K coefficient is what? 18. So now mod of A cross V is V cube upon rho. A cross V mod is 18. Velocity is 5. You V cube upon rho, you get rho. Once you get rho, an is V square upon rho. Substitute the velocity value of V. and rho, you get an. Then tangential acceleration is square root of a square minus n square. Substitute the value of a, substitute the value of an, you get the value of a. And that's what he asked. This type of problems are also very, very important. They ask this type of problems many times in the examination. Okay, students, we move to the next sum, that is problem number 12. The rocket follows a path such that its acceleration is given by x a bar 4I plus tj meter per second square at r bar is equal to 0. It starts from rest. At t is equal to 10 seconds, determine speed of the rocket, radius of curvature, and magnitude of normal and tangential components of the acceleration. This problem also has been asked as it is number of times in the examination. Unknowns are same, working approach will be same, just will work in a reverse manner in comparison to previous problem. In the previous problem, you are given position vector. In this problem, you are given with acceleration vector. If you are given with acceleration vector, that means you are given with ax and ay. So we start with ax. What is ax given to you? 4. You can write dvx upon dt. Separate the terms, integrating both sides. So vx is 4t plus c1. At t is equal to 0, vx is 0. It is given that starts from rest. You get c1 0, vx is 4. At t is equal to 10 seconds, ax is 4, vx is 40. Ay is t given to you here, tj. dvy upon dt, separate terms and integrating both sides, you get vy is equal to t square by 2 plus c2. Put the value of t is equal to 0 and vy is 0, you get c2 as 0. So vy comes out to be 0.5 t square. At t is equal to 10 seconds, ay is 10 meter per second square and vy is 50 meter. So you can write acceleration vector, right? You can write velocity vector. What is acceleration vector? Axi plus ayj. What is velocity vector? Vxi plus vyj. Then you can find magnitude of acceleration, that is a bar, mod of a bar, that is ax square plus ay square, you get 10.77 meter per second. You get magnitude of velocity as mod of v bar, 40 square plus 50 square root of that is 64.6. A cross v will be ijk, ax ay, and this is vx vy. This is going to be 0. Again, it will be only k coefficient. So k coefficient is going to be what here? 4 into 50, that is 200, minus 400. So minus 200k. Mod of a cross v is v cube upon rho. A cross v is 200 and v is 64.03 whole cube upon rho. So rho is arrived. Once you get rho, an is v square upon rho. Substitute the value of v and rho, you get an. And tangential acceleration is square root of a square minus an square. Substitute the value of a, substitute the value of an, you get tangential acceleration. All right. Let's move to the next sum. I'm reading the sum. A particle moves in xy plane with acceleration 3I minus 16 tj. That means you are given, as in the last sum, acceleration vector is given. It starts at the origin with starting velocity v0, that is 50 meter per second, directed at 30 degree to x-axis. That means this time the boundary conditions are given to you. You are given with the initial velocity which is directed at 30 degree to x-axis. So that means at t is equal to 0, vx and vy are to be worked out as shown in this diagram. Can you see that? v0 is given 50 at 30 degrees. So vx will be 50 cos 30, vy will be 50 sin 30. So at t is equal to 0, vx is 50 cos 30, that is 43.3. vy is 50 sin 30, 25 meter per second. All right. Acceleration vector ax and ay is given. Ax is 3, minus 3. Sorry. All right. So that will be written as dvx upon dt. Separate the terms, integrating both sides. You get vx is minus 3t plus c1. Vx value is given 43.3 and at t is equal to 0. So c1 comes 43.3. So vx is minus 3t plus 43.3. At t is equal to 2 seconds, you get ax minus 3. Vx, substitute the value of t into 2, you will get it plus 37. Acceleration component in y direction is minus 16t equal to dvy upon dt. Separate the terms, integrating both sides. Vy is minus 16t square by 2 plus c2. Boundary condition at t is equal to 0, vy is 25. Just substitute it, you get C2 as 25. Dy is minus 8t square plus 25. At t is equal to 2 seconds, substitute the value of it into Ay and dy. Ay is minus 16t, so it is minus 32 meter per second. Dy, substitute the value of t as 2 seconds, you get it minus 7 meter per second. With that, students, you got acceleration vector as axi plus ayj minus 3i minus 32j. Velocity vector vxi plus uyj, substitute value of vx and uy. Acceleration, magnitude acceleration is mod of acceleration, that is ax square plus ay square root. You got a acceleration. Velocity vector is mod of velocity vector, vx square plus uy square root of it, you get 37.9. Then a cross v is ijk, ax, ay, az is 0, vx, vy, vz is 0. So you get 1214.6. Then mod of a cross v is v cube upon rho. Mod of a cross v is 1214.6. Velocity is substituted, you get radius of curvature. Then normal acceleration is v square upon rho. Substitute value of v and rho, you get a. And tangential acceleration is square root of a square minus an square. Substitute the value of a, substitute the value of an, you get the tangential acceleration. So I think with this, we have covered 13 problems on curvilinear motion. Curvilinear motion, in this part, we have covered the problems of curvilinear motion, where the particle has its own mechanism to have its own motion, right? Whereas in the previous part, we had covered the problems of curvilinear motion, where the object is given some initial velocity in any direction other than vertical, and subsequent motion is under the influence of gravity. That means in the previous part, we had covered the problems of projectile motion, which were subjected to only acceleration due to gravity. So projectile is a special case of curvilinear motion, which was covered in the previous lecture. So in this lecture, we have covered 13 problems. All right, all types of problems have been covered, right? Still, if you want to refer to more problems, you can refer to my book. All right, and many more solved problems are given. Even some practice problems are given. All right, even MCQs are also given in the book. The book is available in the local bookstores as well as on Amazon. On the Amazon, we have arranged for some discount and free delivery. The Amazon link is given in the video description of this lecture. All right. Make sure that the QR code for watching the video lectures is free. Even if you can share the QR code with your friends, so they will also be benefited by watching my lectures, video lectures. Even if they do not want to buy the book, still they will understand the good major part of the lecture. All right, so buying the book is not that essential, but if you buy the book, it will be better because you'll come across many more solved problems, as well as maybe some practice problems, MCQs, and all that will also be there. Okay. In the next lecture, we will be covering my next lecture will be on kinematics of rigid bodies. Thank you.